This question asks what was altered in the system to generate the second curve, and we need to explain why. We have two Maxwell Boltzmann curves. A Maxwell Boltzmann curve shows how kinetic energy is distributed amongst particles in a system. Looking at graph 1, we can see that the bulk of the area under the peak shows that a large proportion of the particles in the system, or we could say most of the particles, have a relatively low kinetic energy, and only a small proportion of the particles have very high kinetic energy. The same is true even when the graph is shifted to the right, as is the case with the second curve. Again, most particles have a relatively low kinetic energy, and only a small proportion have high kinetic energy. So what changed in the system to move the curve from position 1 to position 2? We can see that the second curve is shifted to higher kinetic energies and is slightly flattened. So graph 2 represents the system with higher kinetic energies, and it will therefore also have a higher average kinetic energy. Now, average kinetic energy is proportional to temperature. In fact, temperature is a measure of the average kinetic energy of particles in a system. So since the average kinetic energy increases from graph 1 to graph 2, temperature increases too. We can deduce that graph 1 represents a lower initial temperature and graph 2 represents a higher final temperature. So the change is that temperature was increased. The explanation is that the second curve is shifted to the right and a larger fraction of particles have higher kinetic energy.